Hello, everyone. So today we should really talk about the first part of your inheritance lecture. And just notice that we already released your new part for week number 8, part B for inheritance. And that one there is going to involve typecasting and also instance of operator. I would say that might be the trickiest part for the inheritance discussion, but you definitely need week number 7, which is what we're going to discuss today. If you got any questions, ask me today. But if you haven't finished studying the lecture yet, you want to reach out to me as soon as you can. It's a tricky topic, as I said. You definitely need time to digest. Quick announcement before we go on to the Google Doc question. As I said, lecture number, week number 8, it was released just yesterday, and we're going to discuss that next Wednesday. Okay, you got exactly 1 week to plan your time for study. And especially you want to pay attention to the topics of typecasts. And there are actually many things to actually cover in the typecast you will see. And also something about instance of operator. And it is coming, but later on for your written test number 3, you will actually be asked a question about inheritance. So you really want to plan your time well to really get ready for that. And also the exam as well. All right, and your programming test number 2 is going to happen tomorrow according to your semester calendar. Let me just briefly tell you that we already made available the solution walkthrough for your lab number 2 and also lab number 3. For your lab number 2, pay more attention to the exception handling part. So about the exceptions, and also for your lab number 3, pay more attention to the equals method and also the copy constructor. Okay. Right, so these are the main topics actually for you to review for the programming test. And also, you got some practice programming tests as well. And I believe that one there is also going to be some exercise about the equals method and also copy constructor. I don't think that one contains any exercise for the exceptions. But if you can walk through the solution for lab number 2, make sure you are comfortable of programming with exceptions, like how you create the exception class, how you throw the exception, and also how you include the exception as part of the header of some method. Remember the catch or specify requirements that we spoke about. All right, so that's about the announcement I'd like to make. Do you guys have any questions related to any administrative issues of the course? For your lab number 4, I want you guys to focus more on the programming test number 2 this week. I will try to release it by the end of the coming Monday, but you still got enough time to finish that for lab number 4. So I think I'll just postpone that until next Monday for lab number 4. All right, any other questions? For your written test number 2, I'll release it either today or tomorrow. And then, as I said in the early announcement yesterday, I will also release your programming test 1 and also several labs, the marks for them. You need a particular link, a special link to get access to them. I'll reach out to you by the end of a Friday. All right? Yeah, you will get them by the end of Friday, all of them. Any other questions? Okay, anyone? Any questions related to the course? Any concern? Anything? All right, if no, then I'll move on to the Google Doc question then. Okay, we got about 4 questions. They are rather straightforward, some interesting questions actually, so I can maybe talk about them. Okay. All right, the first one. This one, I believe, is only to clarify some misunderstanding about, of the inheritance, especially the use of the super keyword. If 2 different students register for the same course, wouldn't the attributes number of courses be inaccurate, since the courses are the same but counted twice? I'm not sure how exactly your fellow student may have misunderstood the runtime behavior for this program here, but I think the best way to do it is by visualizing what's happening here, right? So for inheritance, that's your week number 7 lecture, right? Let's recap very quickly. So that's the parent class or superclass, and we got 2 subclasses over here. We got resident students, we got non-resident students, and we got some new attribute premium rates, and also we got some new attribute discount rates, and also we got some overridden method getTuition in both subclasses. And for whenever you want to override some method which you inherit from your parents, you can definitely use the super keyword over here to really reuse the definition, and then you can do something extra. So that's one way to override the method, right? That's something we discussed in the lecture. So I'm not exactly sure what your fellow student is having the misunderstood claim. So I think the best way is to just visualize what's happening quickly. So they were talking about 2 different students register for the same course. So why don't we try to visualize what's happening there, right? What's going to happen? So let's say the following. Let's say I'm gonna say RS for resident students and NRS for non-resident students, just to save some writing. Let's say we got here. Let's say we got 2 student objects. Let's say we got RS. Let's say student number 1 is new resident students. Let's say Jin. Just give a name for the resident students. Let's have another students here. Let's say NRS S2 new NRS. Let's say Alan. So we simply got 2 different students, right? Different kinds. And of course, as you study through the lecture, you realize the static type and the dynamic type, they don't necessarily have to be the same. But here, for simplicity, I simply make them the same. Okay, but we just want to illustrate that we don't have any inconsistency for the counter. Okay, let's say we have also a course. Let's say a course over here. Let's see is, let's say, new, and then course, right? Let's say EECS2030, and then you may put some fee for the course, right? Let me just omit that detail. All right. And you want to register the 2 students into the same course, right? And we can say S1 register. And then let's say C. And we're going to say S2 register. And also C. So they're registered in the same course, right? Notice one thing here. So here we're calling the register method. And the register method is only defined in a single place over here. And this method here will be inherited to both kinds of students, right? It's simply reused. So that's one characteristic of inheritance. You can simply reuse the method from the parent class, and you may or may not actually decide to override it. It's completely up to you. All right. And after this, of course, you can actually say things like, let me just go back there. You can say you want to print out, for example, you want to say system out the print line, s1.getTuition, and followed by maybe another print line, and s2.getTuition. That's what you can do. And of course, as you go through the lecture for week number 7 and 8, you will actually learn that these 2 method calls, even though they're calling the same method over here, but depending on what the dynamic type is for the context objects, different version of the getTuition is going to be called, right? I'll leave that to you actually study that part in the lecture. All right, let's now go back to the original concern over here. Okay, how do we visualize this? Let's do that quickly. S1 and S2, right? So S1 pointing to some students over here, and the type of student is resident students. And one unique feature, one unique attributes about every resident student is their premium rates. I haven't set a premium rate yet, but it's not important for understanding the this particular question, right? That's the premium rates. And let's talk about the second student, S2. So S2 is also pointing to some different objects over here, non-resident students. So non-resident students, and also that one got some unique discount rates, which will be also some value, right? And another attributes will be the number of courses over here, right? And of course, there is also a corresponding array. So that's the programming pattern that we have been practicing, since the beginning of the course. So I'm not gonna include the array into the visualization. Let's just look at the number of courses. That's the attribute being mentioned. So the number of courses is going to be a separate copy between the two. So NOC here as well, right? So in the beginning, there will just be 0 between the two students, right? They're separate copies. And let's now say, as soon as you say S1.register C, what's going to happen is you're going to put the object C into the array for S1. And S1 got some separate array for their list of courses. And you're going to increment the value from 0 to 1 over here, right? And then S2.register over here, you're also going to put the same course. So you're also going to put the same course into a separate array for S2. And in that case, you're also going to increment the value by 1 as well, right? So there's really no double counts because S1 is only registered in one course, which is C, and that's the 2030. And also S2 is also registered in one course, C, that's also 2030. So there's no double count, right? All right, it's a very quick visualization for you, but I think the main lesson is for each child objects, you should really know how to visualize them. You should know what attributes they really contain, like the expectation. And to see that, you have to look at the inheritance hierarchy diagram and accumulate all the attributes from all the parent class and also parents' parents, basically ancestor path, right? That's something we also spoke about in week number 7. Is there any follow-up question to this? Anyone? Any questions? Everybody comfortable with the example here about using super and also about the architecture for one parent class and and maybe multiple subclasses? Everyone's okay? All right, hearing none, let's now move on to the next one. All right. Okay. And this one here, I think it's a good question here. I think maybe your fellow student has a good intention to really try to reproduce the hierarchy over here. You can see that's the smartphone hierarchy. I also gave you the zoom in version for the inheritance hierarchy. Let me just show you how you can find it in case you haven't seen that yet. So you can see under week number 7 over here, you can see on the diagrams, we got multi-level inheritance hierarchy smartphones. And I intentionally didn't give you any source code for week number 7 and 8 because I think you really want to reproduce the hierarchy yourself in Java. And these are, and there will be questions related to how things will work, either in the compilation time or at the runtime. So you really want to reproduce the examples. But I can give you a little bit of help to get started, okay? So I think your fellow student's question was over here. If you're given a hierarchy like this, it's reasonably complicated, but I would say once you get to the 3rd year, for example, for 3311, the software design course, which you will take maybe next year, EECS 3311, right? It's a software design. So when you are really doing some medium-sized software projects, having, I think, how many classes have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 classes. I don't think that's really many. Of course, at this level, you might find that it's actually quite many. But realistically, don't be too surprised if you get to dozens or maybe 30 or even 40 classes in your projects. Of course, you got to organize them into different packages and etc. All right, that's for later, for your 3rd year. All right, so now how do we turn this into Java code? And your fellow student was wondering whether you should go for, should you start at the top or should you start at the bottom? I would say it doesn't really matter. Starting from the top or starting from the bottom is not the question. I think here is, I would say, doing 2 stages, okay? Stage number 1, create empty classes first. Okay, meaning that I'm going to create, for example, I'm going to create, we got one class, smartphone, create one smartphone class that's empty. Create smartphone, create iOS, iPhone SE, iPhone 13 Pro, Android, Huawei P50 Pro, Huawei Mate 40 Pro, Samsung Galaxy S21, Galaxy S21 Plus. Create all these classes, each one of them just be empty. You know how to do that, right? And then, number 2. Implements the extends relations. Each one of them. For example, you can see that there is an arrow, like extends arrow between iOS and also smartphone. So what does that mean? That means you have to go to the definition for iOS and then put the extend keyword over there. So for example, you can see, let me just give you one example here. And you should do for every arrow. So you should have like a public class and then iOS. And now you're going to say extends. Okay, I believe it should be with S over here, right? Just make sure you spell it correctly. Extends. Extends is a keyword and then smartphone. Yep, that should be the class. And you don't need to put anything inside. You can just leave it empty. And you will do the same for every arrow you can see over here. Every arrow should be some extends relationship. But of course, you gotta make sure you put in the right class. You wouldn't say here, for this arrow here, you wouldn't say Android extends Huawei. It should be the other way around, right? So that's how you can recreate the inheritance hierarchy. So once you have done that, you can try it out all the examples that were discussed in the class, in the lecture, right? Especially for week number 8, we have gone through many examples where we have to determine whether the lines of code will compile, or if it compiles, will it run into class cast exception. That's really something you want to try yourself. Okay, so that's about this question here. Any follow-up to it? Anyone? Okay, I will pause for a moment to see if you got any follow-up question to this. All right, hearing none, let's now move on to the next one. Okay, the next question is more about like a design question. Okay, so your fellow student was wondering, let's say we got a new class called FlipPhone, FlipPhone over here, and where should it go, right? The FlipPhone. So your fellow student was wondering whether the FlipPhone should really go here, maybe at the same level as smartphone, maybe like that. And then let these two become the common ancestor for everything else. This would not be allowed actually for Java. Okay, let me just write it down what your fellow student was thinking, and then I'll tell you why it would not be allowed. They were wondering about, can we just put a flip form over here? And then can we just let, for example, well, depends on what the operating system, like operating system is going to run. According to your fellow student, let's say only Android, right? In that case, maybe we can let Android maybe extends both smartphone and also flip phone. Okay, that's what your fellow student was suggesting. Okay, this is not possible in Java. Okay, not possible. A class can only extend a single class in Java. You cannot extend multiple classes. Each class can only extend at most one. At most one class. So in this case, if you simply say extends flip phone and smartphone, it will not work. It's simply syntactically not allowed, right? So let me start from that. Start from there. All right, so this is not possible. So I would suggest maybe something else, right? So these are several questions you could really ask yourself if you want to do this design. First of all, flip phone should still be a smartphone if we can agree that. In that case, if the flip phone is simply like a specialized kind of phone of smartphone, in that case, we can still maintain smartphone as the common ancestor for every phone that we have over here. And we can simply put the flip phone as like a special branch under that. I'll show you, okay? And then let's we can make the assumption that maybe flip phone is only runs Android. I don't think Apple actually supports any flip phone just yet. Maybe they will in the future, but not at the moment. So now we are assuming that flip phone is only going to run Android, let's say. And then maybe flip phone is manufactured by I'm not sure about Samsung and Huawei. I'm not really looking into the brands, but let's say maybe both of them actually support, or none of them, or only one of them support. That's some decision you have to make, right? So based on that, let's now try some hierarchy over here. Okay. So I will still start with the smartphone, right? Everything is a smartphone, so I'll still make it as a top, right? Just only a single top, only a single root. So smartphone over here. And given that the Apple, the iOS, does not support any flip phone, at least for now. So I would say I'll do the following, okay? So this branch over here would just be the same. So this part here will just still be the iOS. Okay, you can think about this part here would just remain the same, this part over here. Okay, yeah, let me draw a little bit better. Okay, so this part remained the same, okay? I'm just not gonna draw that, right? Think about this part here. It's the same, this part, just the same. How about this part over here? What should we do? And on the smartphone, it's you got different ways. What makes sense to me would be, for example, we can say under Android, because we still got some iOS to support. Let's say Android. Okay, let's say Android over here. Okay, under Android, so now we can say either it's a flip phone or it is not a flip phone. So we can say here so this will be the critical part to actually distinguish. So either we can say here, or we can say over here. Okay, so this is maybe non-flip phone. And this one over here will be a flip phone. And this part over here will be a flip phone. Okay, like that. And then I believe all the models I mentioned over here, they are not flip phone. They are not flip phone. Okay, so maybe this part over here, you can simply repeat it over here. So all these over here. So you can think about under the non-flip phone, you got either Huawei or Samsung. And then so these are the example over here, right? And then this part over here, you can do something similar. You can also put Huawei and Samsung under this as well, right? And then you can put some particular brand. Okay, let me just do a little bit more over here. So maybe here, you can, of course, you gotta make sure all the names for the classes are unique. They are not duplicating, right? So maybe over here, one will be, let's say, I'm gonna write it in the shorter form. So maybe Huawei flip phone, and also Samsung flip phone. And then under which you can actually put different brands over here, different models. All right, so that's how I would suggest. But of course, there's no right or wrong about the model. I'm making a certain assumption as I listed over here. So that would be the corresponding design. If you got different assumptions that you believe that should be followed, you might got different hierarchy. But it's just one example design. Okay. All right, any questions? Any follow-up to this? Anyone? All right, hearing none, let's now move on. Okay, so this one here, it's more about the single choice principle, okay? The single choice principle. And your fellow student is wondering, what if we want to add a text feature, let's say to the tuition calculation? I'm not sure. Let's say, just for illustration's sake, I would say the text is very similar to the inflation rate that I spoke about in the lecture, okay? I would say very similar. Similar to the inflation rate. Inflation rates, okay? And let's just use the text over here. So there are two cases over here. So here we got case number one. Let's say the tax rate will be the same. Let's say rate the same for all students, including resident or non-resident students, for all students. Okay, and also we got case number two. Let's say the rates, let's say different between either resident students or non-resident students, depending on which kind you are, right? Let's now talk about these two examples, these two cases, right? Let me use a different color here. Let's say, let me use purple. Let's talk about case number 1. For case number 1, if the rates are simply the same, then I would suggest you should really go to the single place to really modify the getTuition, right? The getTuition, this is the parent version over here, right? You can see that's a parent version. So you can go to this version over here, and as we said before, this one here only calculate the base amount for the tuition. And if the tax rate is simply the same across all the students, in that case, you can simply say maybe tuition, this will be the base amount over here. And they can see simply say multiply by certain text. And text could be some attributes, and maybe can be some parameter that you set, whichever way you like. But my point is, for case number 1, given that the tax rate will just be the same for both kinds of students, you can simply put it in the single place over here. So that means this definition here, tuition multiplied by tax, will be inherited to both students for reuse. All right. So that's that's case number 1. For case number 2, let's say the rates are simply different. Let's say it really depends on what kind of student you have, right? In that case, I would say you don't really need to modify anything to the getTuition. What you need to do is you have to change the overridden version for individual kind of students over here. Right? For example, maybe other than premium rates for resident students, they may have some tax rate. I'll say tax 1. That could be some constant you can set, or maybe some attribute you can set to the resident students. And this one here, it will be multiplied by tax 2. Right? We are not really violating single choice principle, because since for case number 1, it's definitely not, because you're only modifying a single place where which is shared in common between the two kinds of student. For case number 2, we are also not violating single choice principle, because for text number 1, we're only putting that into a single place. And for text number 2, we're also putting that into a single place, right? So that's really the minimum number of places possible we are modifying. So we are still satisfying the single choice principle. Okay. All right. Any follow-up to this? Anyone? I think this question is quite nice, because I think when we talk about the single choice principle, we are really saying that you really want to minimize the duplicates in your code, so that whenever you want to maintain your code by making some changes, the number of places you have to make the change must be minimized. And I'm just showing 2 cases. In both cases, they're simply minimized. So that's why the text example that your fellow student mentioned, it will still satisfy the single choice principle. Okay. All right. Any follow-up question to this? Anyone? Okay, hearing none. So now I'll open the floor to any other question you might have related to this lecture or earlier. Any question you want to ask? Okay, I'll pause for a moment to see if you guys got any questions. It's your time. So if you got questions, I'll answer. If no, we will finish meeting earlier, right? So please, questions. If you're still behind for the inheritance lecture, then I would suggest you really want to catch up, right? Otherwise, when you get to the written test 2 or the exam, you'll definitely struggle even more. It definitely takes time to digest the ideas for inheritance. Okay, can a subclass override a method from its grandparent class? Yes, it is possible, but in the following sense. Okay, it's a good question. Let me just give you the idea. You can definitely try. Okay, I think the simplest example would be, let's say this. Let's say we got one class A, and also we got another class over here, B. Okay, let me just copy the arrow over here. Let's say we got 3 classes, right? So we got the notion about grandparents. Of course, you know, we can just say ancestor. All right, and then we got another class over here, C. Okay, let me give you 2 cases of overriding the grandparents method. Let me give you two examples. So this is one, and this is another one. Okay, let's talk about two cases. Let me set it up. Okay, and then let me give a quick title to this, so later on if you refer to the notes, you will also know what I'm trying to do here. So we are talking about overriding grandparent class method. Okay, so that's really the a question from Xiaohui over here. All right, let's talk about case number one. Case number one could be, let's say this. Let's say we have a method n. Let me just say void n. Okay, and just for simplicity, I will simply just have some print line as the implementation. Just for you can try. It's not a very good style because normally we don't really put system.out print line in your method, but just for for illustration. So here we say print line, and then let's say a.m. Right, is the m method from class A. All right, so that's one method. Yeah. What's going to happen is, let's say for class B, we choose not to override the m method. But in class C, we choose to really override the method that's inherited from B, which indeed is actually inherited from A. So what we can do is we can say void m over here. And then, so here, if you want to override, we can definitely say super dot n, and then we can say print line c dot n. All right, so that's the first. That's a setup. Okay, let's now try to do some code quickly. Okay, let's say here we try to say objects. Let's put some application code. Let's say here. Let me just make it a little bit simpler for you. Let me say, that's okay. Let me just say this. A objects is new C. Let's say object number, let me change it again. Let me do it again. Object number 1, new B. A. Object number 2 is new C. Okay, and then here we're trying to do obj1 dot n, and then obj1 dot n, obj2 dot n. All right, let's say this is 1 and this is 2. All right, so now I'm opening that to everybody. Can you type on the chat if you want to participate? So what should be the output from 1? Just 1. I'm not talking about 2, just 1. This one here, what should be the output? Just this part. All right, I see one answer here. Anybody else? And okay, I can see another one. Sam, why are we getting a.m? Why? Let's say this is a written test question. How would you explain your answer? Why are we getting a.m as the output? B does not have an overridden version. Why is that relevant? You are saying that it does not have the overridden version, so it got inherited from its parent. That's fine. But it's still not talking about the critical points. When we say obj1.m, how do you know which version of the method is being called? How do you know? Dynamic type version. Good. Very good. So that's something you also want to make sure you review for week number 7 and week number 8. So here, the context object, very good. The context object, object number 1, its dynamic type is actually B. So that's why it's going to invoke the version of M that's in B. However, B does not have any overridden version. So that's why we're going to use its parent's version over here. So that's why we're going to use this version. On the other hand, let's say over here, let me just go to the second one as well. So we are calling the same method over here, but the which version you will call depends on the object number 2 dynamic type. That's dynamic binding. So object number 2 has dynamic type C. And in that case, it does have an overridden version over here. So that's why it's going to print out whatever that's from the inherited version from B, which indeed is the version inherited from A. So it's going to print out A.M, followed by C.M. Right? So that's the answer. All right. And the second case I can show to you is like this. In the second case, it could be that, let's say, void M. And in that case, I can again I can say print line A.M. So this is case number 1. And in case number 1, indeed, you're really overriding the version that's inherited from the grandparents, because the parents does not have any overridden method. But now, let's say the parents does have the overridden method. Then are you able to actually override the grandparents version? Let's say void and also M. And over here, print line, and then let's say B.M. And let's say here we say, is it possible to say, rather than overriding this version over here, is it possible to override this version over here? The answer is no, you cannot, right? Because whenever you refer to super, the super keyword, it always refers to the immediate parents above you. You cannot refer to parents. Like, for example, say super.super. As I mentioned in the lecture, it's simply not possible. All right, so if you say void M over here, and then the best you can do is to say super.m. And also, you may want to do something specific to the current class. You can say C.M. But now, it's really important to realize over here, the super over here is really referring to this particular method over here. Okay. Let me just make it a bit thinner. Okay. It's really referring to this method over here. Okay, you cannot refer to this one. You just cannot. You may actually, yeah, so over here, yeah, in this method over here, you may just want to define whatever way you like. What I'm trying to say is, whenever you're trying to say super over here, the best you can reuse is to reuse the version that's from your parents' version over here. You just cannot reuse the version that's from your grandparents in part of your overriding. It's just not possible. Of course, if you simply just copy and paste the line from here to here, right? In some way, you're overriding that version, but that's not what we're talking about. We're talking about whether you can really use some automatic mechanism supported by Java by using the super keyword. But whenever you use a super keyword, you can only refer to the version in your parents. You can never refer to your parents' parents. That's simply not possible. All right, any follow-up question to this? Anyone? All right, so now let's say if you got any new questions, I'll be happy to answer. Anybody? Yeah, it's an exercise for you. You can definitely try to write these lines of code and put in here. And then try to see, if you say obj.m, what's going to be the output? And if you say obj2.m, what's going to be the output? Of course, right now, it's going to depend on which version of the m you're going to call, right? So that should be something you can do. and to make sure you convince yourself it's gonna work. Helia, you got a question?
Hello, professor. Yeah, I have a question about practice exam. Can I ask?
Oh, sorry, I cannot really hear you correctly, clearly. Can you say that again?
Can you hear me now?
I can hear you, but in some way it's not very clear. Can you speak a little bit more slowly so I can hear you correctly?
Okay, I have a question from practice exam. Can I ask from that?
You have a question from the lab or
Practice exam.
practice exam? You mean the practice test?
Yeah.
Okay, what about it?
Can I share my screen?
I think it would be better if I share my screen. I think it would be better. Let me just open up the practice test. You can tell me which line you're talking about. I think that'll be better. If your question is about a specific line of code in your implementation, then we better deal with it in my office hour. But if you got, I can give you. Let me open that. Give me a moment. So let me go to tests and then. Is the question about aggregation or composition? Are you still there?
We can't see your screen.
Is the question about aggregation or composition?
It's composition, but I can't see your screen now. It's on Blackboard.
No. I'm asking. So we got two tests, right? We got either aggregation or composition. Which one is your question?
Composition.
Composition. Okay. And can you tell me which line?
The test case, the last line, I guess.
Which one? You mean this one?
The Y thing, the Assertion, the one before this one.
This one?
Yeah, I'm asking. It is setting x to 100, so why should it be equal to 2 again?
Yeah. Okay. So it's something to do with the composition, right? You can think about it's very similar to the getFloors method for your lab number 3. So you want to think about here when you say lc2 that get line at, you should really implement this method here similar to how you implemented your getFloors for lab 3. So the way to do it is you're going to make sure when you return the get line at, you don't return just the reference for the line. You want to return a deep copy of the line. So that will make sure when you try to set the x, you are not really setting the x to 100 for the original line. You're setting that on the deep copy of the line. So that's why this one here should still remain 2.
But the assert2 is also for copy, I think.
Yeah, you want to do a deep copy. Yes. So here when you implement the get line at method over here, you should really return a deep copy of the line.
Yeah, but it is changing the x of copy and then checking for x of copy. So
no, it's not checking for the extra copy. So every time you actually say lc2 that get line at, is going to return a separate deep copy. So here you call that the first time, it's going to return deep copy number 1. And over here, when you say lc2 that get line at, it's going to return, yes, a deep copy, but it's deep copy number 2. They have nothing to do with each other.
Oh, okay. So setting x equal to 100 do nothing actually, right?
Yeah, so basically when you try to set 100 for the x, you're only setting the 100 on the deep copy of the line. But that deep copy there is not the same as the deep copy over here. They're separate copies. So that's why it would just be 2.
Okay, I get that.
Yeah, make analogy over here. Let's say, let me just make an analogy over here, right? Let's say I got directory, let's say D1 over here. And let's say I got a subdirectory over here. Let's call D2, okay? So now imagine this. If I actually want to, let me just say I got some temp directory over here, okay? Let me say I got D1. Whenever I say D1.get directory, I can just make a deep copy of that. So I'll say copy, and then I'll put it here. Let's say put it here. So you can see this D1 here and this D1, they are equal by their contents, but the references are different. They're just separate copies. And now if I try to, when I say set X to be 100, it's pretty much like I'm trying to maybe rename this directory here to be D34. In that case, I'm only modifying only this deep copy. So later on, when I try to make a deep copy of D1 again, I will still get D2. I'm not getting the D34. So that's kind of what's happening in what should happen in your solution.
Thank you very much.
Okay, good. Okay. Okay, let me close that. All right. Let's see if you got any more question here. All right, any more questions? Anyone? Yeah, I'll pause one more moment to see if we got any more questions. We still have one more session tomorrow. If you want to attend, feel free. All right, seeing none from the chat.
Can I?
Yeah, you want to ask? Yep, go ahead.
I want to ask something else about the last thing. So we have to create a copy whenever we create something new, and whenever we are using a get function to get something.
Okay, about lab number 3. Are you talking about the getFloors method? Is that what you're talking about?
Yeah.
Yeah, what about it? About the getFloors?
I thought we just had to create a copy when we build an object or something. So
Yeah, indeed.
In this case,
So,
we have.
Yeah, go ahead. Go ahead.
We have to create a copy whenever we are returning something.
Yeah, I think the reason that for the getFloors of your lab number 3, you can also refer to the solution walkthrough, which I also said there. So for the getFloors method, because the JUnit test, the starter test, require the return array contains separate copies of the floor. That's actually different from the original ones. So that's why inside the getFloors method, one reasonable way to do it is by calling the copy constructor on the floor class. So whenever you want to fill in the return array, you want to make sure you actually make a deep copy of the floor object first before you return the array. So you're right, the getFloors should really return some deep copy of the floors. But the reason we are doing that is because the starter test require us to do so.
Will it be mentioned in our exam or in our test that we need a copy?
In the actual test, in the actual test, we wouldn't tell you that you're gonna do a deep copy over here. We wouldn't tell you explicitly. That's something you have to infer from the JUnit tests.
Okay.
Mm-hmm.
Thanks.
So I would say whenever you see the JUnit test is trying to compare, for example, references of the return objects and the original one, that should be a very good hint about you should really return some deep copy. On the other hand, if the JUnit test tells you the return objects and the original one are the same objects, their references are the same, that tells you it's not upcomposition. It might just be aggregation, which allows sharing. So you should always find the hints from the starter tests. Okay, good. All right, any more questions? Okay, I'll pause one more moment just to see if you got any question you want to ask me today. Okay. But my advice again would be for week number 8, it really gets tricky about how we can do typecast and also instance of operator. It does take time to really digest the material. If you haven't got a chance to really start, you really want to start as soon as you can. Of course, week number 8 depends on your understanding from week number 7. So please make sure you finish week number 7. I cannot emphasize this anymore. Okay, it's really important. All right, seeing no further questions. Okay, I think I will end the meeting now. If you got any more questions, feel free to drop by my office hour as usual. Okay, or send me an email if you want. All right, guys, take care. See you later.